The aviation world just experienced a seismic shock that nobody saw coming. On December 26, 2024, China unveiled not one, but two revolutionary aircraft that sent shockwaves through every defense establishment on the planet. The larger one, designated the J-36, features engineering choices so bold they defy everything we thought we knew about fighter jet design. 3 engines on a stealth fighter, a weapons bay, measuring 7.66 meters that can swallow missiles most countries don't even possess. A side-by-side cockpit configuration that resembles nothing in modern air combat. American defense officials are scrambling to understand what they're looking at, and the leaked specifications that emerged 3 months later left Pentagon analysts absolutely speechless. This isn't just another fighter jet entering service. This is China announcing to the world that the rules of air combat have fundamentally changed. The power figures they've achieved, the range, capabilities they've demonstrated, the weapon systems they've integrated, all of it points to something unprecedented in modern military aviation. What makes this story even more remarkable is how completely China managed to keep these developments secret. While Western intelligence agencies tracked known programs and anticipated evolutionary improvements, Chinese engineers were building something revolutionary. Welcome to a deep dive into the most significant military aviation development of the decade. The J-36 represents more than technological achievement. It signals a fundamental shift in who dominates the skies and how future wars will be fought. The specifications we're about to reveal will change how you think about air power forever. Because what China has built isn't just impressive, it's a game changer that forces every military on Earth to reconsider their strategies. If you're ready to discover the truth behind China's most advanced fighter, stay with us. What you're about to learn will leave you speechless. The unveiling that shook the world started with grainy videos appearing on Chinese social media. December 26, 2024 wasn't chosen randomly. This date marks Mao Zedong's birthday, and China deliberately selected this symbolic moment to reveal their technological triumph. Within minutes of the first footage going viral, defense analysts worldwide were frantically trying to understand what they were seeing. The J-36's appearance immediately set it apart from every fighter aircraft currently flying. This wasn't an incremental improvement over existing designs, this was something completely different. The tailless flying wing configuration, the massive size, the unconventional proportions, every element challenged conventional fighter design philosophy. Intelligence communities that had been tracking China's 6th-generation fighter programs suddenly realized their assessments had been catastrophically wrong. The aircraft's dimensions tell part of the story. At 23 meters in length with a 19-meter wingspan, the J-36 dwarfs conventional fighters. To put this in perspective, it's significantly larger than the American F-15 Eagle, one of the biggest fighters in service. But size alone doesn't capture what makes this aircraft revolutionary. What China packed into that massive airframe represents engineering decisions that Western designers considered impossible or impractical. The smooth, continuous surfaces of the flying wing design eliminate radar reflection points that plague traditional aircraft shapes. The blended body, where fuselage and wings merge into a single form, presents minimal radar signature from multiple angles. This isn't just stealth. This is a comprehensive approach to low observability that represents significant evolution beyond 5th-generation thinking. The cockpit design revealed another surprise that sent analysts scrambling to revise their assessments. Side-by-side seating for 2 crew members. This configuration, typically seen in bomber aircraft like the B-2 Spirit or fighter bombers such as the F-111, suggests mission requirements that extend far beyond traditional air superiority roles. Each pilot has their own heads-up display and control station, allowing specialized roles during complex missions. One crew member can focus on flying in air combat while the other manages sensors, weapons, and electronic warfare systems. This 2-person crew concept reveals China's vision for 6th-generation air combat. Future battles won't be simple dogfights between individual aircraft. They'll be complex operations involving multiple domains, extensive sensor networks, and coordinated attacks across vast distances. The J-36's crew configuration acknowledges this reality and provides the human capability needed to manage these complex missions effectively. But the feature that truly stunned Western observers was the propulsion system. 3 engines, not the conventional 2 engines found on virtually every modern fighter, but 3 separate power plants integrated into a stealth airframe. This configuration initially seemed absurd to analysts trained in conventional fighter design. Every additional engine adds weight, complexity, and maintenance requirements. Why would China make such an unconventional choice? The answer lies in understanding what sixth-generation fighters must accomplish. These aircraft aren't just weapons platforms. They're flying command centers that must power systems previous generations never contemplated. Advanced electronic warfare suites that can jam entire radar networks. High-energy sensors that map battlefields in real time. Potentially directed energy weapons that require massive amounts of electricity. All of these capabilities demand power levels that traditional twin-engine configurations simply cannot provide. Intelligence estimates suggest the J-36 uses either WS-10C engines or the more advanced WS-15 power plants, the same engines, developed for China's most advanced fighters. But having three of these sophisticated engines fundamentally changes what the aircraft can accomplish. The electrical generation capacity alone represents a quantum leap over existing fighters. Modern warfare increasingly depends on electronic systems, and the J-36's three-engine setup provides power levels typically associated with ground installations, not aircraft. The performance figures that leaked months after the initial unveiling left analysts stunned. The J-36 can reach Mach 2.5 faster than most missiles currently in service, but raw speed only tells part of the performance story. The aircraft can maintain supercruise, flying faster than sound without using afterburners. This capability allows the J-36 to cover vast distances while conserving fuel and remaining harder to detect. Afterburners create massive infrared signatures that reveal aircraft to enemy sensors. Supercruise eliminates this vulnerability while maintaining supersonic performance. The fuel capacity represents another shocking revelation. Intelligence estimates suggest the J-36 can carry between 13 to 15 tons of fuel internally. To understand how extraordinary this is, consider that many smaller fighter aircraft weigh less than 15 tons when fully loaded with fuel and weapons. This enormous fuel capacity translates directly into operational range that rewrites strategic calculations throughout the Pacific region. Range calculations based on observed flights and performance modeling suggest the J-36 can operate up to 4,000 kilometers from its base under standard conditions. With optimized flight profiles and mission planning, this extends to an impressive 6,000 kilometers. Let those numbers sink in for a moment. American bases in Guam, Japan, and potentially even Hawaii fall within striking distance when the J-36 operates from Chinese territory. Forward bases that provided security for decades suddenly find themselves vulnerable to an aircraft that can strike deep and return home without refueling. At supercruise speed, the J-36 can cover 2,700 kilometers in just 1 hour, though this consumes roughly 10 tons of fuel in the process. This capability allows rapid response to developing situations and enables the aircraft to arrive at contested airspace with sufficient fuel reserves for extended combat operations. The strategic implications cannot be overstated. China has developed an aircraft that can project power across distances that were previously the exclusive domain of American military capabilities. The three-engine configuration provides another crucial advantage that Western analysts initially overlooked: redundancy. During long-range operations over hostile territory, losing an engine on a twin-engine fighter means immediate mission abort and a desperate run for safety. The J-36 can lose an entire engine and continue its mission. This redundancy dramatically increases aircraft survivability during deep penetration missions where rescue options don't exist. Advanced engine management systems optimize performance based on flight conditions and mission requirements. During long-range cruise segments, the aircraft might operate on just one or two engines, with the third available for high-demand phases of flight. This flexibility allows mission planners to optimize fuel consumption while maintaining the ability to generate maximum power when needed. But the J-36's most devastating capability lies hidden within its massive airframe. The primary weapons bay measures an unprecedented 7.66 meters in length. To put this in perspective, this weapons bay is longer than many fighter aircraft fuselages. This cavernous internal space can accommodate weapons that simply won't fit in conventional fighters, and China has developed weapons specifically designed to exploit this capability. Intelligence assessments suggest the J-36 can carry 2 YJ-12 supersonic anti-ship missiles simultaneously. These Weapons are game changers for naval warfare. The YJ-12 can engage aircraft carriers at ranges exceeding 400 kilometers while traveling at speeds that make interception extremely difficult with current defense systems. The missile's supersonic speed gives defending ships minimal reaction time, and its range allows the J-36 to launch attacks while remaining outside the engagement envelope of most carrier-based aircraft and ship defense systems. The implications for naval warfare are profound and disturbing for American military planners. Aircraft carriers have been the foundation of American naval power projection for 8 decades. These massive vessels provide mobile air bases that can project power anywhere in the world. But the J-36's combination of range, stealth, and anti-ship missiles transforms carriers from assets into vulnerabilities. A single J-36 carrying 2 YJ-12 missiles represents a credible threat to vessels costing billions of dollars and carrying thousands of sailors. Air-to-air capabilities center around the PL-15 and PL-17 missile systems, and here again, the J-36's internal weapons bay provides decisive advantages. The aircraft can reportedly carry 4 PL-15 long-range radar-guided missiles. These weapons outrange most American air-to-air missiles currently in service. The PL-17, an even more advanced weapon, extends engagement ranges to distances where enemy aircraft may not even detect the J-36's presence. The side weapons bays add mission flexibility to the primary bay's overwhelming firepower. These smaller compartments can house shorter-range missiles for close-in engagements or additional sensor equipment for specialized missions. The 3-bay configuration allows mission planners to customize weapons loads based on specific operational requirements. Internal weapons carriage maintains the aircraft's stealth signature throughout the entire mission. This represents a crucial advantage over fighters that sacrifice stealth when carrying external weapons. The J-36 preserves its low observable characteristics regardless of payload, extending the aircraft's survivability in contested airspace where detection often means destruction. The inlet design showcases sophisticated engineering that balances competing requirements for stealth, engine performance, and structural efficiency. 2 carré-shaped inlets under the wings feed the lower engines, while a dorsal intake behind the cockpit serves the third engine. This arrangement maintains stealth characteristics while providing massive airflow to all 3 power plants. The double delta wing configuration optimizes the aircraft for both subsonic efficiency and supersonic performance. The leading edge features carefully calculated sweep angles that manage airflow across the entire flight envelope. Unlike traditional fighters that compromise between different flight regimes, the J-36's wing design maintains efficiency whether cruising at subsonic speeds or pushing through supersonic flight. China has nicknamed the J-36 the Ginkgo Leaf due to its distinctive shape, but this design serves purposes far beyond aesthetics. The tailless configuration eliminates vertical stabilizers that create large radar returns on conventional aircraft. Every surface angle was calculated to deflect radar waves away from enemy receivers rather than reflecting them back to their source. Sensor integration reaches new levels of sophistication in the J-36. Multiple apertures throughout the aircraft's surface provide comprehensive situational awareness without compromising stealth characteristics. These sensors feed data to advanced processing systems that create a complete tactical picture for the crew. The 2-person cockpit makes sense when you consider the information management requirements. Electronic warfare capabilities appear extensive based on observed antenna configurations. The J-36 can likely jam enemy communications, disrupt radar systems, and potentially disable incoming missiles through electronic means. These capabilities transform the aircraft from a weapons platform into a comprehensive warfare system that can dominate the electromagnetic spectrum. Now let's discuss how the J-36 compares to America's most advanced fighters, because these comparisons reveal the strategic implications of China's achievement. The F-22 Raptor, long considered the world's premier air superiority fighter, suddenly appears limited by its twin-engine configuration and smaller weapons bays. While the F-22 excels in air-to-air combat, its weapons capacity and range fall short of what the J-36 offers. The F-35 Lightning II, America's most numerous fifth-generation fighter, faces even greater challenges when compared to the J-36. The F-35's single engine limits both power generation and redundancy, while its smaller weapons bay severely restricts payload options. Against the J-36, which appears optimized for both roles, the F-35 appears outclassed in key performance areas. The J-36's superior range fundamentally challenges American military strategy in the Pacific theater. Current American plans depend on forward bases in Japan, South Korea, and Guam to project power throughout the region. The J-36's ability to strike these bases while operating from Chinese territory forces a complete reassessment of this strategy. America's response includes the recently announced F-47 developed under the Next Generation Air Dominance Program. President Trump's announcement that Boeing received the contract suggests the United States takes the J-36 threat seriously. However, the F-47 specifications remain classified, making direct comparisons impossible. The strategic implications extend beyond individual aircraft capabilities to affect the entire military balance in the Pacific region. Naval operations face particular challenges from the J-36's capabilities. Its anti-ship missiles threaten surface vessels at distances that exceed many defensive systems engagement ranges. Aircraft carriers must now operate farther from potential conflict zones, reducing their effectiveness. Air defense systems worldwide require updates to counter the J-36's capabilities. Its combination of stealth, speed, and electronic warfare systems challenges existing defensive networks. Countries throughout the region are reassessing their air defense investments in light of this new threat. Alliance structures gain new importance as individual nations recognize their inability to counter the J-36 alone. Cooperative defense arrangements and shared intelligence become essential elements of any effective response strategy. Japan, Australia, South Korea, and other American allies in the region are seeking reassurances and requesting access to technologies that can counter the J-36 threat. The global response to the J-36 reveals its strategic significance. American defense officials immediately began classified briefings on the implications of China's achievement. Allied nations throughout the Pacific region requested briefings on the J-36's potential impact on regional security. European observers note the J-36's implications for their own sixth-generation fighter programs. The Global Combat Air Program involving the United Kingdom, Italy, and Japan faces new pressure to accelerate development timelines. The J-36 has effectively reset the bar for what sixth-generation fighters must accomplish. Intelligence communities worldwide are reassessing their understanding of Chinese military capabilities. The J-36's emergence suggests that previous estimates of Chinese technological progress were dangerously conservative. Western analysts who assumed China remained years behind in key technologies suddenly face evidence that challenges these assumptions. The J-36 program continues active development with regular test flights, providing new insights into the aircraft's capabilities. Each flight reveals additional details about performance, characteristics, and operational requirements. Chinese test pilots are pushing the aircraft through its flight envelope, validating predicted performance and identifying any issues that require correction. Production timelines remain uncertain, but Chinese military aircraft programs typically progress rapidly once flight testing begins. Intelligence estimates suggest initial operational capability could arrive sooner than originally projected. China's demonstrated ability to move from prototype to production faster than Western programs suggests the J-36 could enter service within the next few years. Variant development appears likely based on the J-36's modular design approach. Specialized versions optimized for specific missions could emerge as the program matures. A naval variant for carrier operations seems particularly likely given China's investment in aircraft carrier development. The emergence of the J-36 represents a watershed moment in military aviation development. China's achievement demonstrates technological capabilities that were unimaginable just a decade ago. The aircraft's revolutionary design approaches challenge conventional thinking about fighter aircraft requirements and capabilities. The strategic implications extend beyond any single aircraft or program to affect global military balance and regional security arrangements. Nations worldwide must adapt their defensive postures and technological development priorities in response to capabilities demonstrated by the J-36. The comfortable assumption that Western air forces would maintain technological superiority indefinitely has been shattered. Despite impressive specifications, the J-36 remains in development with operational deployment still a future consideration. Test flight programs must validate theoretical capabilities under realistic conditions. China must build an entire support ecosystem around the J-36 before it can achieve its full operational potential. The J-36 represents more than just another military aircraft. It symbolizes the changing nature of global military competition and technological development. The specifications and capabilities we've discussed today will influence military planning and technological development for years to come. China has announced its arrival as a peer competitor in advanced military aviation, and the world must adjust to this new reality.